Okay, so today we're either going to write ionic formulas or we're going to name ionic formulas. So the first thing we're going to do is write them. So you get the chemical symbol and then the oxidation number, the charge that the atom will have after it becomes an ion. So sodium, again, is in the first column, and so sodium is going to give away one electron. Chlorine being in the 7th or the 17th, depending how you're counting, it will gain one electron. So both of these are 1 to 1, and we have the cation first, which is the positive one, and the anion second. Okay, so technically this would be Na1Cl1, but since we don't write ones, the final answer would be NaCl. Okay, so let's try another one. Let's do magnesium with chlorine. Well, magnesium has an oxidation of 2 plus, and chlorine still has the oxidation of -1. Okay, well, we did this one with our Lewis dot structures on Friday, and so you know that there's 2 electrons here where there's only one place for an electron to go here. So we're actually going to need 2 chlorines. So what we do is we crisscross these numbers. So the 2 goes down here, and then the 1 goes down here. So this ends up being Mg1, because chlorine is 1, and then Cl2. And so, of course, again, we don't write the ones, and so that becomes MgCl2. So let's try another one. Why don't we do aluminum and sulfur, because that one's always a little tricky. So aluminum, again, is in underneath boron, so that's going to be in the 3 plus. And sulfur is underneath oxygen, so that's going to be the 2 minus. Now, if you're wondering where I'm getting these numbers, if you go to the classwork, so you go to classwork, and then at the very top under material, you should see a periodic table, and it says with charges. Okay, and if you find that one, then it has all these numbers. All right, so and when we draw this out, we know there's 3 electrons here that need home, but there's only room for 2. For this example, you go with for the math people, the least common multiple of 3 and 2 is 6, so you need 6 electrons to go in or to be given away, and 6 electrons to be received. So the way we do that is we crisscross. So we're going to need 3 of those and 2 of those. So Al2, right? And then S3. Okay, and that's how we get that one. So you've got, I think, maybe 20 of those to practice. So practice those, and again, upload that assignment when you are done. And I believe that is assignment. Hold on, I'll tell you. Writing ionic formula. So this is assignment number 43. And don't forget, assignments are all due by the end of the school day. So be sure you're doing them during your class time. All right, so let's go to the next part, and that's writing the chemical formula. So remember that the cation stays the same, but it's the anion that gets the IDE at the end. Okay, so the anion gets the IDE. So this one is Ba for barium, right? And then Cl is chlorine. So this one's just going to be barium because it's the cation, and then chlorine is going to change to chloride. Okay, adding that IDE at the end. And so if we do, let's see, we'll do calcium, which is 2, and oxygen, which is also 2. So that would be calcium oxide. And then we can do see, that would be Li2S, and that one would be lithium. And then this would be sulfide. Okay. Now, those are pretty easy because those are all going to be in columns 1 through 2, and then starting with boron, which is 13 through 17. So those are pretty easy to work with. When you get over here, you get, and these are in columns number 3 through 12, and these are the transitions. So when you get to the transitions, it's a little bit trickier. Because if you notice, when you pull up the periodic table of charges, you'll see it's got charges inside the boxes, and the charges can be different. So we have to figure out which one we're talking about. So it's kind of like working backwards with the crisscross. So this one right here is chromium and chlorine. So I know that chlorine normally has a oxidation or a charge of -1. So that means if I uncross this, that 2 came from chromium. So this chromium must have been the +2 version of chromium. And if I do this one, same thing, since chlorine is 1, uncross this 3, and that means that this must be the +3 version of chromium. Now, why does that matter? The reason that that matters is that we have to put a Roman numeral after these in order to let us know which one we're using, because it has to. So instead of just being chromium chloride, this one actually becomes chromium and then Roman numeral 2, because it's the 2 plus chloride. And this one here becomes chromium. Oops, let's spell that right. And then Roman numeral 3 chloride. And so that happens with all of these that have multiple oxidation states. So it's like if I had NiCl2 or NiCl3, this one would be nickel 2, and this one chloride, and this one would be nickel 3 chloride. And that's just because we don't know without seeing the formula which nickel we're talking about. So I need to be able to somehow designate that. So, and you have about 20 practice problems of those also. So, fill those in and then upload that assignment before 3:35 today as well.